with granules. And actually the process of the exocytosis of these granules is very efficient. And sometimes people say that within the granule, if this is part of the cytoplasm here, if I take part of the cytoplasm, so the granules fuse with each other before they fuse with the cell membrane. So when it secretes, it's flushing. It's the amount of secretion that comes out is massive amount of secretions. They don't wait one by one, but they actually fuse with each other, and then all the secretions come out all of a sudden. And this is why sometimes people, if they are allergic to something, the histamine, if it is released, it may cause collapse of that individual. Okay? And it's immediate reaction. So these are mast cells which secrete histamine and heparin and other factors which are found in these granules. So they are granular in shape. How about macrophage? How do they look like? Yes. How macrophage looks like? Circular. Okay. What is the function of macrophage? Engulfing. So would you expect them to be perfectly circular? No. Yeah, in general, yes. At very low magnification, they may appear circular, but actually they have processes. They are involved in phagocytosis. So you should expect them to be something like this. A macrophage will have something like this. Cytoplasm that is, of course, you may not see this under the microscope. You may just see a circular cell. But what defines macrophage?
Acidophilic cytoplasm.
Acidophilic cytoplasm. Okay. Actually, the cytoplasm can be acidophilic or basophilic or both. Why?
Depends on the
Because it depends on what does it phagocytose. Okay? It's like a trash can inside the tissues. The trash can can have glass, unless there is segregation, or separation like what we have here in the college. But you can expect that the cytoplasm may have some basophilic cytoplasm of a debris of a cell, and also it may have some cytoplasm that is rich in mitochondria. This will be acidophilic, and may have a nucleus of a cell. This will be basophilic, and so on. So when you look at the cytoplasm of a macrophage, it has different basophilia and acidophilia, and it looks like a trash can inside the tissue section, or in the tissue section. So it has different structures inside the cytoplasm. And this is what characterizes it. You cannot define it if it is inactive macrophage. It's difficult to tell this is a macrophage. But in general, if you would like to describe macrophage, it has processes, so it has irregular cytoplasm, it has a lot of lysosomal bodies, it has phagosomes, different shapes of different phagosomes. How about plasma cells? So this is macrophage. How about plasma cells? Produce antibodies, and antibodies are produced. Which organelles are involved in the production of antibodies? Which organelles are involved in the production of the antibodies? Cytoplasmic organelles. ER. So they are very rich in rough endoplasmic reticulum. They look something like this. Yes, excellent, with eccentric nucleus. So the nucleus is pushed toward one side, and there is an area here which is negatively stained. But the rest of the cytoplasm is packed with rough ER. So there is a lot of basophilia here. So this would be basophilic cytoplasm. Dark basophilic cytoplasm. So there is a lot of rough endoplasmic, no secretion granules. So the cytoplasm looks more homogeneous and basophilic, and there is an area that is not basophilic. It's neutral, and this is the area of the Golgi. We call it negative Golgi image. So eccentric nucleus toward one side, basophilic cytoplasm, and negative Golgi image. So all of these are features of the plasma cells. So this is mast cell. Another feature for mast cell is what? The granules are they contain heparin, and heparin is sulfated, like sulfated proteoglycans or sulfated glycosaminoglycans in the matrix of cartilage. And this makes the mast cells metachromatic. They are basophilic, yes, but at the same time they are metachromatic. Like the slide that we have, slide number 82 in the slide box, which is a section in the elbow joint. It was used to demonstrate mast cells, and they appear between the muscle fibers or between the collagen fibers around the joint. Okay? Is it clear? Does this answer your question? Of course, you need to look at the slide to see these by yourself. So you need to look at the slide to see these by yourself. It's difficult to tell you how it looks like unless you examine the slide and you visualize the slide by yourself. Any other questions? Yes? Plasma cells, are they always basophilic? Yes. Yes, they are basophilic. Where do they come from, plasma cells? What is the origin of plasma cells? B lymphocytes. So when B lymphocytes are activated, they differentiate and become plasma cells. If it is a plasma cell, it has to be basophilic because it is a differentiated B lymphocyte. Okay? Even B lymphocyte is slightly basophilic, but B lymphocytes have smaller shape. They look like this. And this is a nucleus, more heterochromatic, and the cytoplasm around it is very thin rim of cytoplasm, very thin halo of cytoplasm that looks basophilic, pale basophilic, pale basophilic. But this one is dark basophilic. Not very dark, but it is obvious basophilic because of the amount of rough ER. So when it differentiates, it becomes this. And there is another feature for the nucleus. I'm not sure whether Dr. Adigati mentioned it. For the nucleus, if you look at the nucleus, what do you see? The chromatin is segregated at the periphery and it takes the shape of a clock. So it looks like this, the nucleus. So you can see 12 o'clock, 3 o'clock, 6 o'clock. So you can see like clumps of chromatin attached to the nuclear envelope, and it takes the shape of a clock. That's why they call it, when they describe plasma cells, they say that it has a nucleus with a clock face appearance. Clock face appearance. Okay? Is it clear? Now, any other questions? Okay. Shall I go on with the slide? Yes.
Can you explain the zone of the epiphyseal plate?
The zones of the epiphyseal plate. I have one slide for this here. So the zones of the epiphyseal plate, we said there are several zones in the epiphyseal plate, starting from the area that face so this is the epiphysis, this is the epiphyseal plate, this is the metaphysis, and the diaphysis is down here. Okay, is it clear? So starting from the epiphyseal side here, you have a zone of resting cartilage. So it looks like resting cartilage. You can see chondrocytes in lacuna surrounded by matrix of cartilage, widely separated from each other. Next zone, they call it the zone of cell proliferation, because chondrocytes appear as if they are proliferating. They are on top of each other and they are packed. So initially it looks like this. Chondrocytes widely separated from each other. And then you see chondrocytes like these. This is the zone of cell proliferation. And then you start to see that the chondrocytes enlarge. They call it the zone of hypertrophy. And when they undergo hypertrophy, the matrix here is calcified. So calcium salt deposit in the matrix. And this could be a reason why the chondrocytes start to undergo hypertrophy and they die. And when they die, they leave these empty spaces. So inside here you have chondrocytes. But here it's dead already, the chondrocyte. And then when they die, they call it the zone of cell death. And then what will happen with the empty space? It will be invaded by blood vessels from this side here, from the metaphyseal side. Blood vessels will enter this empty space, and they are surrounded by mesenchymal cells. Mesenchymal cells will find nice, smooth surface. They will attach to the surface and become osteoblast, or osteoprogenitor cells first, and then osteoblast. And osteoblast become osteocyte, and they become surrounded by bone. So you start to have bone around the cartilage. So here you will have bone. So this zone here, they call it, so the same thing happens here. The zone of mixed spicules. So you have, or the zone of ossification. So you have bone that develops in the middle, you have cartilage. So cartilage is here, the cartilage matrix is here, but on the sides of the cartilage you have bone. And I think most of you have seen this in the practical, right? Okay? So zone of resting cartilage, proliferation, hypertrophy, calcification and cell death, and then ossification. Okay? Is it clear? Any other questions? Yes?
You told us before that the osteoblasts are always on the surface.
They are always on the surface.
Sometimes there's osteoclasts on the surface.
Yes.
So where do they originate from, the osteoclasts?
Where do they come from, osteoclasts? From monocytes. So they come from the surface also. They come from outside. So osteoblast and osteoclast, both are found on the surface, and both originate from the connective tissue around them. So in the connective tissue you have some macrophages. Macrophages come from where? From bone marrow, monocytes. So bone marrow has stem cells that give rise to monocytes that circulate in the blood, and then it leaves the bloodstream to reach the connective tissue. And in the connective tissue they become macrophage. And macrophages fuse with each other to form an osteoclast on the surface of the bone. Yeah? It sounds a bit weird that you may see osteoclast next to osteoblast, but this is the case. So you may have the majority of the surface, or most of the surface area of the bone is covered by osteoblast, but you find areas where there are scattered osteoclasts. Why these specific areas have osteoclasts? Why not somewhere else? I don't know. Probably there is something that attracts them. Maybe there is, usually macrophages are attracted to areas where there is tension. Yes, these are physical properties. But I'm talking about macrophage. If there is a cell dying in a tissue, this will attract macrophages. If a cell dies in the liver, the connective tissue in the liver will immediately have, you will see immediately that there is a macrophage that will try to come and phagocytose this dead cell. So maybe because some osteocytes becoming old and they start to disintegrate, usually they say that when cells die, they release some factors that attract macrophages and immune cells to come and get rid of them, to clean them. Okay? So probably this is why they are found on specific areas on the surface. And it can vary from place to place, depending on the attracting factors that bring them there. Okay? Any other questions? Okay. I just would like to remind you that with this slide that we showed in the first section, the first lecture, I told you that pathologists would like us to make sure that you cover these topics that you will need for next year pathology course. So we cover